Okay. So this is just a parabola that opens what, upward or downward? Downward. So it makes sense. You throw a baseball up, it comes back down, right? So how many seconds is the ball? After how many seconds is the ball 12 feet high? How do we solve that one? So that's basically what we're solving here is when is.
Your screen is frozen.
Oh, it's still frozen. We're asking when is S of t equal to 0? Right? No, we're not asking that. That's the next one. When is it equal to 12? So there's a few ways to do this. Shall we do it by hand? So the easy way to do it is on a calculator. You just press intersect. You put a 12 on Y2. You put this on Y1, and then you see when are they. Let me do it that way first, just to show you. Decimals. So if all else fails, you graph it. And then you could graph 12. Why is this so weird? Okay, there we are. So you throw it up, you throw it down. Now this is obviously going to go higher because it's on the moon, right? So let's 0 to 20. Let's change this up a bit. We start at 0 and let's go to 20. Now you guys can do this all in your calculator. I'm just doing it up here because it looks a little bit nicer on the screen. So here we have, this is what we have. Now I want to know when it's equal to 12. So on your calculator, I could just solve this, right? And what is the answer? 0.186 and 10.925. Is that what you guys got? Yes? No? Maybe so?
Instead of t, do we put in x?
You would use x, yeah, on yours. Now another way to do it, so there's two ways to do this that I taught you guys before. One is you can do y1 equals y2 and then you use the intersect, right? So that's kind of what that graph did. The other way is you can do y1 minus y2. Now think about this. If I subtract y2 from both sides, what am I going to get on the right hand side? 0, right? So I could just go back to my original. I'll get this thing open up while I'm here. So then I could just go back to my original one and say, you know what, subtract 12 from this. And then now I'm looking for the zeros. The zeros are 0.186 and 10.925. You guys see that? So that's one way to do it. By hand, it's going to be a mess. What do these numbers tell us? 1.86 and 10.925. They tell us that these might be ugly numbers to begin with. Huh? Shall we?
I just put a line in the graph.
For which one? Y equals 12?
First part.
Press zoom 6.
I did. Did you put in the equation for like one of them, like y1, and then the second equation would just be 12? Yeah, the straight line.
All right, this is what I'm gonna do. I'm gonna do it.
Yeah.
Now you got a line that went straight up. Is that what you're talking about? Yeah. So remember I had to change my window too? Well, this is a good problem to just do. I should have just started on this. Okay, let me type it in. Negative 2.7, oops. Negative 2.7 x squared so that's a good question that Isabel asked, and we're gonna analyze this. Now what I'm gonna do is I'm gonna do the second. I'm just gonna do the zeros because intersect requires 2. I'm just gonna subtract 12, okay? So would you guys agree that if I solve the zeros of this, I solve the question? So see the minus 12? All right, so I graphed this. Now I'm gonna go zoom standard and it's gonna look weird. And I don't even see the bottom part, right? So I'm gonna change my window to be, first of all, we gotta find where it crosses. So I'm gonna go from 0, because I don't really care about negative time. Because, you know, I'm just here to have a positive time. So 20 times. So let's see if this one looks any better. So at least I know that now it's going up and coming down within 20. Now how high does this go? Let's see. How high does it go? We don't even care how high it goes, right? Because the question is just saying, when is it equal to 12? That's the zeros of this, right? So all I did was I changed my window to be 0 to 20, because that's my time, right? I don't care about negative time and 20. I got it. Now it goes higher than this for sure. I don't really care how high it goes, because that's not the question. If the question was how high does it get, then I would zoom out and then do maximum. Okay. All I care about is my zeros here. So I'm going to go to second, calc, 0. Left bound, I'm going to go. Now, the problem is the cursor is way up here in the ceiling, okay? I can't see it. So I'm going to use this Y to be my guide, okay? I want this to get close to 0. So at 8, 1, 2, 3, 4, 5, 6, 7, it's way up here, right? So I'm just going to first of all go to about what x equals 0, but notice that the numbers are dropping. And then now all of a sudden it shows up, okay? I want it to be negative. It doesn't, now you could go more, but this is enough. You see how it's negative here? Now I want it to be positive. It's positive, right? If it's negative here and then positive here, it has to cross 0 at some point. Would you agree? So I press enter, and then the guess, you just press enter. 0.186. You guys see that? Yes. No. Maybe so. So what we're doing here is, you know, I'll just put this over here, and then we're all happy. So I did a 0 here. Now, do we want to solve it by hand? That's one of the answers. Because it actually hits 12 twice. It hits 12 when you throw it up, and then back on the way down.
One last question. When I did it, I thought that we put for y2 12. So like it's like a straight line and then the curved line.
If you do that, then you use intersect instead.
Okay, so they're done the two things.
The reason I like using 0 is because then there's just one function to deal with, not two functions. Okay.
12 that the y-intercept said it's at 0 at x. Is that what we're looking at?
When you do the minus 12, when you only have one function and you put the minus 12 up there, you look for the 0. If you do the y1 and y2, then you do intersect. What I'm saying is I personally prefer the 0. Because, then you're just always finding zeros, and I don't know. This whole chapter is going to be about finding zeros anyways, so might as well get in the habit.
So what is the final answer?
One answer is 1.86, 0.186, and what's the other answer?
I have 10.9.
And then there's another one, 10.925. There's two answers.
So do we have, like, how would we represent that? Like,
You gotta do this again. So that's why it says left, and so that's a good question. I'm gonna do it right now. 0. Now notice there's 2 zeros. So now I want to find the other one. So I'm gonna go way over here. Notice that I'm using these numbers as a guide. It's still positive, and then there it is. Too far. Okay, is that positive? Yes. Then I'm going to go a little bit negative. If it's positive here and negative here, it has to cross 0 at some point. 10.925. Right? Yes, you are correct. It makes complete sense to me. Or not, I don't know. So we're gonna put this one right here, and then we're gonna put the other one right here. So our answers are 0.186 and 10.925. Now, when does the ball hit the ground? Question?
what?
Do you have any question,
I was trying to.
or maybe trying to see it?
Yeah.
So, anyone else?
So then what answer would be non for the final answer? What answer is the final answer?
What answer is the final answer?
The 10?
Both of them, right? So, all right. So here. So let's say I'm 3 foot right here. Well, I'll stand up. So I'm 6 foot, right? And I want to know, when is this piece of paper going to hit the 7 foot mark? Okay. So when I throw it up, it's going to hit it once, right? Going to keep going up, and on the way down, it's going to hit 7 foot again, right? Boom, boom. So how many answers are there? Does that make sense?
So do you have to do those two?
There's 2 answers, yes. This is an answer, and this is an answer.
So like for the final answer, you have to find both. The zero.
You have to find both.
Okay.
It does hit 7 foot. Now, if the question said, when does it first hit it? Well, actually, does it say when does it first hit it? No, it doesn't. Now, the question could have been, when is the first time it hits 12 feet? The question could be, when is the last time it hits 12 feet? Then you have to think about it a little bit more. So, make sense? Now, when is it going to hit the ground? So what I'm going to do now is I'm going to alter my y equals to not have this 12 at the end. It's just the original function, and I want to know, when is it 0? So, I'm going to graph it. So does this make sense? I start up here, and I throw it up, and it comes back down. It's going to be 0 somewhere over here. So I'm going to go to second, trace, calc, 0. So I'm using my numbers as a guide, because it's way out there.
Why do you go to 0 instead of finishing that?
What I go what?
Why do you go to 0?
Because I want to find where it's equal to 0. When it hits the ground, it's 0. So always remember that on these problems, whenever we have a projectile problem, it hits the surface, that means the height is 0. Okay? So, I don't need all this junk here. Clear. I don't need that. That's what the problem is. It wasn't big enough. So now I'm clearly on the left-hand side and I'm positive. And then I'm on the right-hand side and I'm negative. So when does it hit the ground? At 11.32. Do you guys get that answer? So guess how much like hardcore math, you know, by hand, analytical I did. Not very much. Now notice this y value. Remember we saw this last time? What does this y value mean? This y value is not 0, is it? Or is it? It is? What does this mean again?
Oh, it's like 0, 0, 0, 0, 0.
It means there's 11 zeros. 0.00000000001. It's round off error, which to us is pretty close to 0, right? If you had 0.000000001 of a pizza, it would be like a little, you know, the Parmesan, one fleck of Parmesan cheese.
Did you do the guess on there?
I always did the guess.
Because I'm trying to do it, but it only does how we got the other answer.
It should work.
It's not letting.
Are you sure you're negative? Are you sure you're positive on the left and negative on the right? So in this problem, we just move it up by 12, and we see that the answer is right there. Got it?
Wait, so can you do that one more time? Like, just what you did, like what you just said?
What I just did here?
Yeah.
I just got rid of the 12.
That's it? And
Yeah. It's the same thing I did here. I just got rid of the 12. Remember I had a minus 12? And I want the 0.
I got error.
If you got an error, that probably means you didn't go to the left and right of it. So here's the thing. That's a good question. So let's say I choose I'll use this to really emphasize it. Let's say I use my left bound to be over here at 8. And let's say my right bound is 10. Am I going to find a 0 between 8 and 10? No. So there's going to be an error, right? You have to change signs at some point. If you don't change signs, there's no 0.
So you just got rid of the 12, right?
Yeah. All right. Now let's move on. This is the wrong class. This class. Okay. So notice what my answers were. My answers were, look at the picture. Now, you know how you have to solve this if you don't have a graphing calculator? Because it's not going to factor. Quadratic formula, huh? So how hard was this to solve with your calculator? It's like I said, it's going to take 30 seconds. Once you type it in, second, calc, 0, boom, done. So don't forget this on the test. Your calculator is a very powerful tool. If you don't know anything about quadratic functions, you just graph it. The answers will be given to you with the calculator. Okay, so now we're going to solve. We started 3.3 last time, but we're going to focus on the quadratic equations now. Now we know how to solve every linear problem out there. Now we want to learn how to solve every quadratic problem out there. So So first of all, notice that we always set it equal to 0. Always set equal to 0. Okay. Now the zero product property is going to be our most powerful thing in this chapter. It's something you've been doing all along, but you just didn't know it's called the zero product property. Did I mention this last time? I think I did, huh? So you guys already know this. When you have this, you just do this and that. So solve well, since we did do this, this should be really easy. Actually, let's solve another one. I think we solved this one like 5 times last time. X squared minus 6x plus 9 equals 0. So the first question you ask yourself is, can you factor? Yes. How does this factor? X minus 3 times x minus 3. This is another way to write this is x minus 3 squared, right? So my answers are x equals just one answer. Now, what does this look like when I graph it? So if I graph this, I know that x equals 3, 1, 2, 3, is a 0. I know that this graph, is it going to open upward or downward? Is it like this, or is it like this? Up. Does it go through? Does it, well, let's do what we did last time. Suppose this was a nice smooth parabola. So now I'm going to do my linear transformations, which is called using my mouse. Does it look like this? Does it look like this? Why doesn't it look like this?
There's 2 zeros and then we have
Because then there's 2 zeros. I would have found the other 0 here. It doesn't look like this either, because then there's another 0. If there's only 1 0, there's only one possibility. See that? So whenever you have, what we do is we call this a 0. A 0, that's my hero. We call this a 0 of multiplicity. What number do you think I'm going to use? Of multiplicity. Hint, there's an arrow facing it. 2, right? This 0 is actually of multiplicity 2. This is going to be important. So notice when it's multiplicity 2, it touches the x-axis and then bounces back. Bounces. It does not pass through the x-axis. It touches it, bounces back. So these are the easiest ones to solve. These are problems you were solving in Math 122, Math 97, Math 89, all those classes. Now let's up the ante a bit. Square root property. So we have x squared equals k. So this is the same as x squared minus k. This is, it doesn't look like it, but it's kind of a difference of squares. You guys remember the difference of squares formula? When you have a squared minus b squared, it's a plus b, a minus b, right? If that doesn't make sense, start from the right-hand side and FOIL it, and you'll see that you get this, right? Plus ab minus ab equals 0. The a squared and the b squared come out. So, just notice this thing is not focused. All right. So, where were we? Oh, did you guys get the link I sent to these videos on D12? Okay. You don't ever have to watch them, but if it's a Friday night and you're lonely and you want to hear some jokes or something.
That's what I did yesterday, man. Subscribe to you.
Yep. Subscribe. Make sure you like right here. Point right here. Yeah. So, all right. What was I going to do? Oh yeah, so this is going to become, well, what's the square here? Here it's obviously x. Here it's square root of k. Because square root of k squared is k. Okay? Or not okay? It's like, it's after lunch, just leave me alone. All right, x plus square root of k times x minus square root of k. So therefore x equals plus or minus the square root of k. So the point here is that when you're solving something like x squared equals 25, a lot of people will say, oh, it's 5. It's not 5. It's plus or minus 5. Because you don't know what I'm thinking. I could have been like, I have a number, -5, and I square it and I get 25. Well, you don't know. So that's the square root property. X squared equals k. The answer is going to be x equals square root. See, I'm already wrong.
It's plus or minus.
Plus or minus, yep. He's got this. So let's solve 2 problems right now. This should take you about a minute. No more than a minute, more than an hour. So notice that these are quadratic formulas, right? These are degree 2 polynomials. But what we're doing now is we're upping it. We're making them harder. And then we're going to make it a little bit harder after this. And then one more time harder. And then we'll move on. So the square root property is powerful. If you have a square on the left-hand side, you can solve the problem. Do I have a square on the left-hand side?
Yes.
Well, I do, but it's not completely square, right? It's one step away from being square. What would I do to 2x squared equals -10 to make it square? I would. What's the first thing I would do here?
Times the other side.
Right. Now is this a square? It's a perfect square, right? Whenever you have a perfect square all by itself, you're happy. And you know it. Clap your hands. You're happy and you know. So what's the answer?
Plus or minus 5?
No.
The square root of 5.
Now remember, 3.1 was complex numbers, remember? Yeah, well, no, it's not 5i. It's the square root of 5. If this was negative 25, then it would be 5i. If I had x squared equals negative 25, that would be 5i. But this is not that problem. Now remember, 3.1, we have complex numbers. Complex numbers are now allowed in this class. They were banned before under a executive order. But so yeah, just remember that. I. Now how do I solve this one? I don't know. You might say I want to FOIL this out, but then you would be making life more difficult. You would FOIL your plans at an easy life. X minus 1 squared equals 7. Is the left-hand side a perfect square?
Wait, what'd you do?
What did I do?
We divided both sides.
Everyone good? Is the left-hand side a perfect square?
No.
Well, it's something squared, right? So it must be a perfect square. Then yes. Well, yes. Yeah. We won't get into it. There's a square, we're happy. So this is what, whenever we have something that's a perfect square, I'm gonna write this down because it's important. When you have a square on the LHS, what does LHS mean? It means Laguna High School. Then you solve, right? I don't think we have any L's in Tucson, right? Any high schools that begin with L? Loser high school. I can't think of one. All right. So what do I do now? Square root both sides. This is how you know you can solve it, right? You have a perfect square. You take the square root. Now how easy is this to solve? Now I am skipping intermediate steps. I'm not putting the plus one, stuff like that, but so we have an exact answer. Having a square root on the left-hand side leads you to an exact answer. Now, 1 plus, like if you did this on your calculator and did zeros, you would have, I don't know, 1 plus, you'd have like 3 point something, I don't know. But this is an exact answer. Square root of 7, right? So now we understand the importance of a healthy breakfast. All right. Let's do this now. Now you're only allowed to use what we know so far. Have I shown you guys the quadratic formula yet? No, so you're not allowed to use it. You're forbidden. How do you solve this? Can I factor this? Nope. What are the factors of 2? 1 and 2. There's no way to get a 4 out of 1 and 2, right? So what do I do? Wouldn't it be nice Now you got that song stuck in your head, right?
Which one?
Wouldn't it be nice?
Oh.
Wouldn't it be nice if there was, is it there was or there were?
It's not English.
It's not English. It's all Greek to me. If there was a square on the Laguna High School, wouldn't it be nice if there was a square on the left-hand side? Wouldn't it? Because if the left-hand side is perfectly squared, then I can solve. Right? Would you guys agree that if there was one, it would be nice and lovely and we would be happy? Do you guys agree? So now I'm going to be a life coach now. Make it happen.
So just move the 2 to the other side and then do the difference in square.
Make it happen. No one's holding you back. This is the power of mathematics. I can do crazy stuff, right? I can manipulate left and right hand side. Well, this too is complicating stuff. So what I'm going to do is I'm going to move it over. All right? I could. Okay, so that's a good point. I could move both over and then I have a perfect square, but then I have this x on the other side. And so I'm not taking the square root of a number, I'm taking the square root of a x plus 2 or something, and that's going to be ugly. Now this is what we're going to do. Make it happen. So what we're going to do is we're going to close our eyes and meditate. I learned this trick in The Secret, right? If we all imagine ourselves being millionaires, it happens. Right? Otherwise, it wouldn't be a best-selling book. You telling me Oprah's lying to me? So, no. So meditation won't work here. How else can we make it happen? Complete the square. And I might call this CTS. So, complete the square. I'll call it CTS, but please don't call it CPS for torturing young people in this class. Everyone's over 18, right? All right, so I'm torturing adults, so I'm safe. All right. Now, what would be nice here? Now, here's a secret. You see this number right here in front of the X? Block it from your phone. You don't want to know your X's number, okay? So, you take half of it, and then you square it. Half squared, half squared, half squared. Remember that. Half squared. What was I just saying?
Half square.
Half squared. What was that again? Half squared. What's half of -4?
-2.
Well, not the half. Yeah. The square root of radical 2 pi. -2 squared is,
4.
it's always going to be a positive number, okay? Because a square is always positive. That number you put over here. Now you have 2 kids here, and the left-hand side says, "Oh, you just gave them $4." And then your other kid, who's named right-hand side, because you give your kids weird names, says, "That's not fair. You gave him $4. What should you do to the other kid?"
$4.
Right? Buy his silence. You know. If I give you $4 here, I better give the right-hand side $4, right? What do you do if he complains? Right. There's other ways to shut him up, right? Yeah. Son, bring me the duct tape. Just joking. All right. So now here's the magic. Remember this. Remember this because pretty soon we're not going to have numbers anymore. We're going to have weird letters, and so you're going to want to know this. Now, can you guys factor this up here? Can you guys see how to factor this? But also notice this. Whatever number is right there automatically goes right there. Remember that for later, because pretty soon we're going to have some craziness right here. And we want to just be assured that whatever number is right here, this -2 drops down automatically. Do you guys see how x minus 2 squared is equal to this up here? You guys agree? Now here's the hard part. Get out your calculators. 4 minus 2. You guys got it? You guys still typing it in? Is it still computing? 2, right? Now what did we say over here? When you have a square on the left-hand side, then solve. Do we have a square on the left-hand side?
Yes.
Can we solve it?
Yes.
I'm going to give you guys 30 seconds to solve it. I'll jump in 30 seconds. You guys solve it? So we take the square root of both sides, and then we're done. Now we're going to make this even harder. Okay, do you guys understand this? Okay, now let's make it harder. Okay. Now what makes this problem more difficult? At 8. So what? How do I get rid of the 8? Right, I divide everything by 8. Uh-oh. Uh-oh. Now, is this question any harder than the previous one? No, except for one thing. Fractions. Now, fractions are just numbers. They need love too, right? They're no different than anyone else. They're just numbers like everything else. And yet, because we're so afraid, they always feel so divided. So, I don't know. Fractions, whenever I mention fractions, it always causes a lot of division in this class. So, okay, I'm out of fraction jokes. What is the mantra?
Take half.
Half. Now, fractions look scary But just remember, taking half of a fraction is as simple as putting a 2 on the bottom. Oops, 2 times 4. That's all half means 1/2, right? So it's just 1/8, right? No big deal. Half of 1/4 is 1/8. If I have a pizza and one of them is broken up into 8 slices and another one has 4 slices, the one with 4 slices is going to be twice as big, right? Maybe. No comment. I don't want to talk about it. Sensitive subject. What do I do next? And that's going to be 1 over
64.
that goes here. And now your right hand side kid is complaining. How come he got 1/64 of a dollar? I want 1/64 of a dollar too. Like, all right, here. Now what I'm going to do is I'm just going to simplify this now. Now your calculators do fractions, right? So I'm just going to do this now. What is it? 24 plus 1 over 64. Your calculators, if you do this on your calculator and press math frac, it will give you this answer, right? So I just did LCD here and everything. Now, if I were to give you this on a test, you might freak out. If I said, please factor the left-hand side, you might say, no, I don't want to. What was the trick here? Whatever number is right there goes right there. That's why it's magic. It already factors it for you. Right? This problem in and of itself looks hard. But you created it in a nice way that you already know the answer. And then what's the right hand side? 25/64. Now I'll give you guys another 30 seconds to solve it. You guys get it? Now, so I don't have to scroll down, I'm gonna go over here. It's x plus 1/8 equals plus or minus 5/8. How did I get 5/8? Yeah, square root of 25, square root of 64. Now we get x equals negative 1/8 plus or minus 5/8. Now you don't want to put this into my math lab because it'll complain. The two answers are negative 1 plus 5 over 8, which is
1/2.
1/2. And the other answer is negative 1 minus 5 over 8, which is negative 3/4. In other words, simplify it. So don't put this in the mind math, but put 1/2 comma negative 3/4. I think right now is a good time to take a break because I'm going to do something really crazy after this. Okay. Now this is what we're going to solve. Is ready?
Yeah.
How do you say, where are the numbers at? The numbers are right there, and right there. Solve. Now here's the thing, if you follow the last problem we did, you will solve this. It's like almost line for line the same. What was the first thing we didn't like about the last problem? Well, there's two things we did, right? The last problem, the one with the 8x squared. First of all, that problem looked like this, right? Now this is almost exactly the same problem as the previous one. What was the first thing we did? We divided by 8, right? Because we didn't like it. So, before, well, I won't go into it right now. 8 is the bad number. Sometimes it's 7. It's because 6 was telling me about 7. So I'm mad at 7. 7, 8, 9. All right. X squared plus b over a just because they're fractions doesn't mean they're evil people.
So you divided A by both sides.
Divided everything by a. Now, what was the next step? Look at the previous problem we did. Half squared, right? Half of this is just put a 2 on the bottom, right? Square it, and then put that up here. I'm gonna need more space here, so I'm gonna. I'm already forgetting what I have here. It's A, right? Now, what does your left-hand child say? Hey, if you're going to give him b squared over 4a squared dollars, I want b squared over 4a squared dollars. You're like, all right, here. Here's your b squared over 4a squared dollars. What was the next step? Factoring, right? Well, now this is what I said. If I would have given you this problem on a test, you might have a heart attack, right? If I was like, why don't you go factor this? You'd freak out, right? What's special about it? It's already factored for us, right? That's an easy problem to factor. Now, let's work this out over here. This is nasty. What's the LCD here? 4a squared. What does this need to become a 4a squared?
4a.
This one needs a 4a times c. This one is fine. Right? This c needs a 4. So in other words, it's times 4a times 4a. Would you guys agree with that? Now what I'm going to do is, I don't like starting with negatives. I'm trying to get off on a positive note. Right? Tired of your negativity. So we're going to do b squared minus 4ac over 4a squared, which just comes from right here. Now, what did I say earlier? When you have the left-hand side as a square, you're happy, right? But you guys aren't happy. Because if you're happy and you know it, you'd clap your hands. We're happy. Success! The left-hand side is just this. The right-hand side is the square root of b squared minus 4ac over 2a. Well, I got to get this b to the other side, so I'm going to x equals negative b plus or minus b squared minus 4ac all over 2a.
Wouldn't the 4 on top also be a 2?
No, you can't separate. Like if you
Aren't you squaring it?
I am squaring it, but I can't.
Square rooting the whole thing?
I'm square rooting the top, but I can't separate this from the b squared
Then how'd you get the 2 on the bottom?
because this was by itself. There was no plus. If this was a squared plus 3, I couldn't take the square root. This doesn't even get a circle, it gets a cloud. The quadratic formula. This solves every single second degree polynomial that exists, not just in Tucson, not just in Arizona, not just in the United States or even the Earth, but in the entire universe. All of them. Solves them all. So what this means is when you come across a second degree polynomial, you're like, I'm good. I can figure you out. Do you have a question?
Yeah. I wasn't paying attention. How did you get again to
Honesty is good.
I was jotting down notes,
What happened?
The 2a, how did you get to 2a from 4a squared?
Yeah, I'm still confused.
So to go from here to here, I had to take the square root of both sides, right?
Yeah.
So what I'm doing here,
4a squared is basically, you can square it.
so what I did here was I did x plus b over 2a squared, the square root of this
Gets rid of it.
equals, and then the square root, you can break it up between top and bottom, right?
Yeah.
Now what's the square root of 4a squared?
2a. Órale.
Any other
So
questions?
if the 4ac was by itself, then it would be a 2?
Yes. It would be a 2 radical AC.
Wouldn't it be?
Oh, if it was by itself, yes. Yeah. It's tricky. Radicals trip us up. And just for what it's worth, the next chapter is radicals. So radicals will trip us up.
How long is chapter 3?
Like 12 feet.
When's our next exam?
In the future. It'll probably be after spring break. Probably that week after spring break. I was thinking the day after St. Patrick's Day, so when you guys are all nice and sobered up and
Isn't that on the Friday?
oh yeah, it's
During
on.
spring break?
It's during spring break. The first day of spring is the 21st, maybe then.
The first exam was on Valentine's Day, now the first day of spring.
I don't know yet. It'll be after spring break. The reason I don't know is because I don't know how much time you guys will need to go over this. Because I could just finish it all by next week and give you a test in next week. Or not, right? So it's going to be depending on you guys. Like,
We should do it after spring break. We have a whole week to study.
yeah. So I know everyone's going to be in Rocky Point on the beach with the My Math Lab open and
Watching your videos.
watching. It's going to be cool though, because think about it, you're going to be on the beach in Rocky Point and you're going to be like, hey, what are you watching? And then you're both going to be watching me. You're going to both be watching my lectures. You're going to say, I know Morales. And then you'll buy each other margaritas. In fact, if the Border Patrol detains you, just show them my videos. I know this guy. And they'll be sure to never let you in. So. Well, I got busted with the Border Patrol because they found out that I was a weapon of math instruction, and so I was teaching algebra to a sect of. Never mind. So it's dangerous to be a weapon of math instruction. Now, what's important here? What's also important here is, speaking of Donald Trump, is the discriminant. The discriminant is this part under the radical. This tells you what kind of answers you're going to have. So if b squared minus 4ac, if it's positive, you're going to have plus or minus a positive number, right? So you're going to have two real solutions. If it's equal to 0, you're going to have plus 0 and minus 0. Well, that's just nothing, right? It's just you stay the same. And I'm not going to say our president's negative, but what happens here is you have imaginary solutions to problems that don't exist. So you have two complex solutions. The radical here is what determines everything. Everything is fine except, well, there's two things that go wrong, right? What did I say? You're either dividing by a by 0 or you're taking the square root of a negative number. Now here, what happens if I'm dividing by, what if a is equal to 0?
0.
I'm dividing by 0, right? But why don't I worry about it? Because if a was 0, this would just be a linear function. I wouldn't even be worrying about this quadratic part, right? If a was 0, this would just be, it's like an mx plus b problem. So a is not going to be 0, because then it's not a quadratic problem. So you can tell how many solutions you have based on this discriminant. Now let's try this previous problem again. Let's solve this using the quadratic formula. Remember, to solve any problem in this class, you always set it equal to 0, right? So I'm even going to do that for you. That's how concerned I am. I will do it for you.
Concerned that we can do it or we can't?
I'm just concerned. Pause. Now the quadratic formula is something you should definitely memorize in this class. I actually recommend a little tattoo on your wrist. Because I can't prohibit you bringing your own tattoo to this class for the test. So. You guys get it? So A is 8, B is 2, C is -3. So x equals -2 plus or minus square root of 64 minus plus 4, 12, 96 all over 16.
No, it wasn't 96. The top should be 100.
Yeah.
Yeah.
4 plus 97.
A squared.
Psych. 4a 48 plus 48. 16 times 3 is 48, right? Well, you said it's 100?
Yeah. It's 2 squared.
B squared, not A squared.
Yep. I was just testing you guys out. So this is b squared is 4 minus b squared minus 4ac.
96.
Like I said, it was just 100, right?
Show off. Trying to get in your head.
So -2 plus or minus 10 over 16. Whenever you have numbers you want to simplify, it's -2 plus 10 over 16 is 1/2. And then negative 2 minus 10 over 16 is negative 12 over 16. That's negative 3/4. Does that match up with our answers we got before? Bam. 1/2, negative 3/4. Now this is still a lot of work. Now I kind of skipped some steps because I was doing it in my head, right? But this is a lot of, you know, question.
Isn't there plus or minus? Once you get okay, no, never mind.
Well, I did the, yeah, here's plus or minus.
Uh-huh.
And then I broke it up into, so it's not really equals, it's more of a,
Okay.
it's more of like that.
You said one solution.
Now, here's a secret. You can all be millionaires. Whenever you have fractions as your final answers, that means you could have factored it the whole time. Is that true here? Or am I lying? I could be lying. Solve this by factoring. Say what? Factor by, solve by factoring. Is it possible?
Yeah.
Well, it is because I said so. Try it.
How'd you get 1/2 from negative 2 plus 10 divided by 16?
10 minus 2 is 8. 8 divided by 16 is 1. How do we factor this? You guys remember the AC method? So, A times C, 8 times negative 3 is negative 24, right? What can I add? What factors of negative 24 when I add together give me 2? I'm thinking around 6 and 4-ish. So 6 and negative 4 give me negative 2, positive 2, right? So what I'm going to do is I'm going to change this 2x into a 6 minus 4. So I'm going to do 8x squared plus 6x minus 4x minus 3. Are there any questions of what I just did? I rewrote the 2 as 6 minus 4. What's special about that? What's special about that is I can factor by grouping. 2x, 4x plus 3 minus 4x plus 3 equals 0. Now I'm happy. So if there's no number here, it's secretly a 1. And now I get x equals 1/2 negative 3/4. Same answers. How many ways did we solve this problem already?
3.
3 ways. I could have also graphed it and found the zeros, right? So there's 4 ways. Could have done all kinds of things. I could have graphed the left-hand side and the right-hand side and did intersect. That's 5 ways.
Is there a way to tell if you can factor it just by looking at the problem?
Yeah, it's, you have to do this in your head really quick. The answer is yes and no. The way, so like when I'm helping students out and I need to factor some, I'm actually doing this really quickly in my head, this method here. So for example, that's a good question. So when we did this problem earlier, how did I convince you guys you can't factor it? I looked at 2 and really quick in my head I said, okay, 1 and 2, how am I going to get a 4 out of that? You can't. You know, you exhaust the possibilities right away. So on this one, there might be another way, and it has to do with the discriminant, because the discriminant is what's going to cause trouble. So if your discriminant is a perfect square, you'll have a fraction. Can you guys see that? Because everything else is going to be a number. If you're so that's your answer, I guess. I never even thought about that in my whole life until right now. If the discriminant is a perfect square, you could factor it. How come no one ever told me that ever?
You just told yourself.
Yeah, I discovered something new today. So
Talk about it too.
I'm gonna write my own math book. The Adventures. How telling funny jokes in class doesn't work with students. Solve this. Solve it however you want. Any way that you want. What's the very first thing you should do?
Try to set it equal to 0.
Set it equal to 0. This question should take about 10 seconds to solve. Because it's a very special question. Let's see what's special about it. X squared minus 2x equals 2x minus 2. X squared minus 4x plus 2 equals 0. Now, what's so special about this question? Didn't I just show it to you like 5 seconds ago? So why can we solve it in 10 seconds? Because we already solved it. It was 2 plus or minus square root of 2. Now, of course, that's kind of a trick, right? So you guys should have done, x equals 4 plus or minus the square root of 16 minus 8 over 2. Now, here's a lot of mistakes will happen at this point. You must remember, well, let me factor this out. This is going to be 2 radical 2. A lot of students will write on the test 2 plus this. They'll write 2 plus 2 radical 2. Because they'll cancel out the 4 and the 2, and they'll get this answer. Now, why is that wrong?
They didn't divide the 2 radical 2.
Right. So a little way to do this is you can just kind of write a 2 here. And just remember that everything has to be divided by 2. Okay, so technically it's not mathematically correct, it's not 22 or whatever, but you can see that it's what I'm doing here. It's 2, and then is it false or is it 2? That was bad. Now 3.4 is word problems. And well, every problem is going to be different. So let me choose a really good one. Well, a lot of them are going to come down to inequalities. So let's do x, 3x minus 1 less than negative 4. So they're going to say make the area less than 50 or make sure your costs aren't more than $25 or whatever. So you're going to solve something like this. Question? Now we actually did inequalities last time in class, remember? Toward the end. I'm gonna make this your get out of class early card. Did I take attendance already? No. So if you solve this and you show me the answer, and if it's right, you can go